Hi everyone, here's the practice quiz for Unit 6. Number 1, function f of x is equal to 3 times 1.1 to the x power. Gives the length in inches of an image after being enlarged by 10% x times. What is the length of the image after it has been enlarged 4 times? Round your answer to the nearest hundreds. So x represents the amount of times it is enlarged. And we could see here that we have to enlarge it 4 times. So we're going to substitute the 4 in for x. So f of 4 is equal to 3 times 1.1 to the power of 4. Now for that, you can use your calculator to punch that in. Remember the calculator, you can find it at decimals.com. So if I punch that into the calculator, I get 4.3923. But if you want to round it to the nearest hundred, so that's only 2 decimal points. So we want our answer to be 4.39. All right. So the length of the image after it has been enlarged 4 times is 4.39 inches. All right. Number 2, we're going to graph each exponential function. So for these, we're going to make a table of values and substitute values into the function to get the result. So what I'm going to do is I'm going to pick numbers before and after 0. So we could start with -2, -1, 0, 1, and 2. Okay, so if x is -2, we're going to plug it into the function, 3 to the -2 power. Remember with our rules of exponents, when you have a negative exponent, it goes to the bottom of the fraction. So it's going to be 1 over 3 to the second power, which is 1 over 9. 3 to the -1 power, again, we have a negative exponent, so it goes to the bottom. So it's 1/3. 3 to the 0 power, anything to the 0 power is 1. 3 to the first power is 3. 3 to the second power is 9. And since we have space, 3 to the third power is 3 times 3 times 3, which is 27. So let's go ahead and substitute those values in. I mean, let's graph these table of values. So we have our x and we have our y. So -2 and 1/9, that's a very, very small number, very, very close to 0. Okay. -1, -1/3. So take a look at the scale here, so be careful. So -1, I'm sorry. This is -1 here, and this is +1. This is 3. And then going up, it's going up by 2, so this is actually 2, 4, 6, 8, and then 10. Okay. So just be careful with that. So -1, 1/3 is probably like around there. 0, 1 is here. 1, 3 is here. 2, 9, and then 3, 27. So 27 would be, let's see, 20, 22, 24, 26. So it's going to be about there. Okay. And then once you have your dots, you go ahead and connect them with a nice curve, like so. Okay, and the next one, f of x is equal to 1/2 to the x power. Again, let's go ahead and do our table of values. So, and then let's go ahead again. Let's start the same way with -2. Actually, let's go ahead and start with -3 since we have space. So 1/2 to the power of -3. Again, you go to decimals.com, use the calculator, type this in. This is going to give you +8. So -1, -2, -3, all the way up to 8. You plug in -2, and you get 4. So -2, 4. And plug in -1, you get +2. And you plug in 0. Anything to the power of 0 is 1. And you plug in 1. 1/2 to the first power is 1/2. That's 1, 2, 3. Let's do one more. 1/2 to the second power is 1/4, which is about here. And we're going to connect these with a nice curve. Okay, so that's a review of graphing. One thing to notice, the first one, this one is exponential growth because your base is bigger than 1. And then the one on the right, since our multiplier is 1/2, this one is exponential decay. Anything less than 1 is going to be decay. Anything more than 1 is going to be growth. Okay, number 3, are the following functions exponential or linear? So to check this, I'm gonna move all these points into a table so I could analyze the pattern. So -2, -6, -1, -5, 0, -4, 1, -3, and 2, -2. Okay, notice over here on the left, the pattern is that you're adding 1 each time. That's the pattern. And then over here on the right, again, you're also adding 1. -6 plus 1 is -5, plus 1 is -4, plus 1 is -3, plus 1 is -2. Okay. The pattern is addition. So if you're adding by the same amount, this is going to be linear. Because you are adding a constant amount. Okay. Let's try next one. So -2, -24, -1, -12, 0, -6, and 1, -3. Okay, let's analyze this one. So -2, -1, 0, 1, adding 1 each time. But over here, the y values, negative 24 to negative 12 to negative 6 to negative 3, notice that you get half every time. Every time it's half of the previous one. So you're multiplying by 1/2. You're dividing by 2, but um, you want to describe the graph with multiplication. So you're multiplying by 1/2. So this one is exponential because you are multiplying by constant amount. Okay. So if your pattern is addition, it's linear. If your pattern is multiplication, it's going to be exponential. All right, and then review for properties of exponents. Okay, 2m to the third power times n to the second power times 2 times m squared times n squared. Remember the regular numbers, just go ahead and multiply. 2 times 2, that's going to be 4. And now the ones with the same base, you add the exponents. So for the m, we're going to add the 3 and the 2 to get 5. And then for the n, we're going to add the 2 and the 2 to get 4. Your answer is 4m to the 5th, m to the 4th, n to the 4th. All right, this is the product property. Okay. For number 7, yx squared to the 4th power. This is a power of a power. So this is the power property. So for these, you're going to distribute the exponent on the outside. Remember, if something doesn't have an exponent, it's automatically 1. Okay, so y is to the first power. So you're going to multiply this 4 with the exponents on the inside to get a y to the 4th, x to the 8th. Okay, that's the power property. And then for number 8, ab to the third power over 3a to the third power b to the second power. When you have a fraction like this, when you're dividing, and we're going to apply the quotient property. So numbers with the same base, you could go ahead and subtract the exponents. Okay. I'm going to draw a fraction bar just to get us going. There's no number on top. There's a 3 on the bottom. That regular 3 just stays there, okay? Because you cannot simplify it. If there was like for example, if like a 6 here, then you could divide 6 by 3 to get 2. But since there's nothing there, you just leave it. Well, technically there's a 1, but 1 times ab to the third power is just ab to the third power. So if you want to write 1/3 at the beginning, that's fine as well. Okay. Remember, a has an exponent of 1. So we're going to subtract 1 minus 3 to get a to the negative 2 power. And then we're going to subtract 3 minus 2 to get b to the first power. And remember that the negative exponents, you move it to the bottom. So that a, we're going to go, is now it's going to be in the bottom. It's going to be 3a squared in the bottom. I'm not going to write the 1 anymore because 1 times anything is just that anything. And then b to the first power, it's just b. That's your answer.